Hey, this is Benjamin. Let's see what we can do for the Internet of Holy Delights road test. We want to connect an RGB LED strip to the Internet of Things. So I bought an LED strip off Amazon for like 25 euros. And then we're going to use an RGB LED shield from Infineon. We will need to solder stacking headers because the board doesn't have any, and then we're going to use a breadboard to help connect to the RGB strip. So these guys are going to be used as well. In terms of power supply, we want to use a DC jack power adapter, as well as, of course, wires. We're going to reuse the power supply that comes with the LED strip, and then our best friend, the Arduino Yun, is going to help us connect to MQTT and to Wi-Fi. So let's start by soldering the board. And this is our Arduino shield that's finished. Now we need to connect the power supply using the DC jack. Careful with the polarity. Let's see if the shield fits. We're going to use extra headers because of the Ethernet connector. Well, it fits. So we just need to connect the RGB wires to the LED strip wires using the breadboard. Okay, so first we want to build a web application that will allow us to pick a color on a color wheel and send it using MQTT. So we will have an HTML file with our color wheel. We're going to use a JavaScript library to replace this div with an actual color wheel. And we will also use MQTT over WebSockets, so we include the script there. And then comes our main JavaScript application. And actually what we want to do is make sure that we use the color wheel library to replace the color wheel large div with the actual color wheel. The color will initially be blue, and whenever the color will change, we will change the value of the color variable. Okay. Actually, what we want is we want to make sure that we don't send the color every time the color changes. So what we will do is send the color every 100 milliseconds. We will send the color. Okay. So then we use the Paro MQTT over WebSocket library. We connect to the iot.eclipse.org broker. We generate a random client ID. And whenever we are successfully connected, we will be ready to send colors, right? So as I said, every 10 times per second, we will check whether we need to send the color or not. And if we do, well, we will craft an MQTT message. We want to take the RGB string representation of the color. We don't want to have the hash sign in front of it. It's going to be easier to process on the Arduino. We post on a specific topic, we send the message, and voila. Okay, so now we're going to have a quick look at the Arduino application. So we're going to run on the Yun, right? So we want to use, for the network connectivity, we're going to use the Yun bridge. So I won't explain how to configure the Wi-Fi connection on your Yun, but it's really super straightforward. So yeah, basically the second core on the Arduino Yun is going to take care of mounting the network, and from the Arduino we will have direct access to the IP stack. Okay, so maybe we can start by having a look at the callback that's going to be called whenever an MQTT message is going to be received. So the payload of the MQTT message, if you remember, is in RGB string representation. So we're going to use the string to long method to parse the string and turn that into a long. Once we have a long, we extract the red, green, and blue channels. And that's going to be what we want to send to the shield. So for that we use I2C, and this is basically some code that is taken from the sample that comes with the Infineon shield. So we write 6 bytes on a specific I2C register. The red, green, and blue channels are actually 12 bits each. So we need to shift our red, green, and blue channels. So that's the callback. How do we set up the MQTT client? Well, I've tweaked the PAHO embedded client a bit so as it can support the YUN. And so basically what you do is provide an abstraction of your IP stack to the MQTT client. And well, once you have the client, you can provide, implement the connection workflow, which would essentially be asking the YUN bridge to connect to the iot.eclipse.org broker. Then once we are connected TCP-wise, we want to actually connect MQTT-wise, and then subscribe to the topic where we will receive the colors, right? So now, so that was basically two methods that are going to be called. One is the callback, the other is the connection method. And then the setup and the loop, the good old Arduino methods. So in the setup, we want to initialize I2C. We want to initialize the YUN bridge, the serial communication for debug purposes. Then we connect to the MQTT broker. You might want to change the intensity of your LEDs. Careful though, it depends on how long your LED strip actually is. It depends on your LED strip basically, so careful to not use too big values here. And then the loop, the Arduino loop, is basically gonna be an infinite loop where we ask our MQTT client to process the MQTT messages that might be incoming, and that's all basically. And this is the final result with the application running on my Android phone, sending colors to the Arduino over MQTT and Wi-Fi. So I hope this gives you cool ideas for the challenge. Good luck to everyone, and don't forget to subscribe to the YouTube channel. Bye.